So let's get going. My name is Nicolai. I'll talk about myself later maybe, because I'm here to talk about the module system. But even with that, I don't want to start right away, because they're breaking news that I just saw this morning. I just want to share them with you. They're not even really connected to the module system. But still, I find them very interesting, and so I want to tell you about them. Before we come to the really news, I want to tell you some old news. You probably know that Oracle JDK and OpenJDK isn't quite the same thing. There's slight differences between the two, and Oracle is working on aligning them, so by the time Java 11 comes out, Oracle JDK and OpenJDK are basically the same thing, except that you can't get Oracle JDK for free anymore. From Java 11 on, we'll all be limited to either getting an OpenJDK build from somewhere or paying someone for a supported version. For example, Oracle for the Oracle JDK. The interesting part is that Oracle will ship their own OpenJDK builds, and will be able to download them on their site. But they will only do that for the current version, for the current major version. So you get 10 comes out, then you get 2 updates. Then 11 comes out, then you get 2 updates. Then 12 comes out, you get 2 updates, and I think you can see where this is going. The interesting part is that it doesn't continue after 11.04. 11 is a long-term support release, you might have heard, but it's only a long-term support release if you pay Oracle for that long-term support. The OpenJDK builds that Oracle ships will not, Oracle will not merge changes into OpenJDK, into the 11 branch after 12 was released. So that's not quite that new, but you need that to, for the next slides that come. If you want to read more on that, I wrote a weekly newsletter specifically about this topic. But now let's get to the news. So this morning, actually I think what happened yesterday evening, but I didn't see it. Oracle put out a new, what's called Java Client Roadmap Update. So it outlined plans for applets, WebStart, JavaFX, and Swing. And if all you're doing is web backends, then nothing of that interests you for the next couple of minutes, but I'm sure you'll stick with me. If you're developing a desktop application, though, this should be really interesting to you. So first of all, applets are deprecated in Java 9, and they will be phased out of Java SE by the time 11 comes out. And the OpenJDK builds that Oracle ships, and I will assume pretty much anybody else will ship, will not include applets. So that's rather boring. Quite surprising to me, the same is true for WebStart. I knew it was deprecated in 9, but this is the first time that I heard that Oracle actually made plans when to remove it. So the same as just said for applets is true for WebStart. If you get OpenJDK builds, then from Oracle, then from September on, there won't be a WebStart in there anymore. Next we come to JavaFX. So JavaFX was never part of Java SE, and that also meant that it was usually not included in OpenJDK builds, specifically not in Oracle's OpenJDK builds. So now that Oracle wants to align OpenJDK and Oracle JDK, people kind of hoped that maybe we could standardize JavaFX, and then we could have JavaFX in the OpenJDK builds. But Oracle is going the other way, so they're removing JavaFX from their own JDK, and there's no move made by Oracle to include it in OpenJDK builds or in the standard. So that means if your project uses JavaFX from September on, if your clients use current versions, you cannot rely any longer that they actually have JavaFX on their machine. There's an OpenJFX project, and you can download their builds, and some, I think Ubuntu, for example, or Arch Linux, these even have packages for OpenJFX, so you can install them into your OpenJDK, install on that machine. But it might make things a little bit more complicated. I have a quote for you that also concerns JavaFX. Oracle says it's working with interested third parties to make it easier to build and maintain JavaFX as a separate distributable open source module. After all we've seen over the last couple of months, I think it's fair to assume, or at least to guess, that this might be the first steps towards totally removing the investment into JavaFX and finding maybe some, like Eclipse Foundation, somebody else who's going to maintain that and going to further improve it. So the second part is of course not a quote, I made that up, but to me it seems like a fair summary. What I found most shocking actually was the Swing AWT part. So again to quote, Oracle will continue developing Swing and AWT in Java SE 8, and you can of course pay for Java SE 8 support, and Java SE 11. This means they will be supported by Oracle through at least 2026. So in the past, I took these quotes like a declaration of intention and interpreted some things, and I thought those would be fine. But over the last couple of months, it happened that Oracle later put out a road plan, for example, for the OpenJDK 8 updates, where you thought, wait, didn't they just say something else a couple of months ago? But when you look closely, they didn't actually say something else a couple of months ago. They said exactly what they were going to do. They just left out a couple of bits So what it doesn't say, that this support is free. So Oracle supports it under 2026 can just mean they support it on the Oracle JDK that you have to pay for until 2026. And also doesn't say that support goes beyond Java 11. So hypothetically, and this is I'm sure this is not going to happen, but hypothetically, Oracle could remove swing and AWT in Java 12 and it will still comply with the quote that I gave you. Again, I'm not saying they will do that. I'm sure they won't. But we should, like the community, I think should be more aware that maybe desktop technologies in Java are slowly going to be phased out, and that we should have to step up and find and eventually pay someone to support or to improve the development, to improve these projects. Okay, so I hope now I shocked you into silence. If you're interested in more breaking news, I usually tweet these when I find out about them or write a weekly newsletter. I invite you all to subscribe. But now I actually want to come to the module system, unless you have questions about this. If you can scream loud enough so I can hear you here, you can just ask. No? Well, okay, that's fine. Let's start then with the module system. This is a talk that's going to focus on advanced features. They're not advanced because they're more complicated, they're just advanced because they're built on the basics. So I kind of have to assume that you know the basics. So hands up if you ever wrote a module info Java file. That's about half. Hands up if you ever read about a module info Java file, like in some blog post or book. More people, that's great. Okay, so I assume you will know the basics. I'll go through them very quickly to make sure, but I won't waste too much time with them. And then, of course, the module system is huge and there's lots to talk about. I'll just pick a couple things, try to give you a somewhat complete picture, but there are a lot of other things that I have to leave out, of course. And you can see the slides online already if you go to slides.cornfx.org. So let's start with the basics and the very, very short version. The very short version is that modules, unlike jars, have a unique name, can express dependencies, and can define a meaningful API. Where in a jar, everything that's public is public for everybody. In a module, you can have things that are public inside the module and other things that are public outside the module. All this information are defined in the module info Java file that I just mentioned, and the compiler will compile it into a module info class file. You put that into a jar's root, and hence you don't have a plain jar anymore, but now if you're a modular jar, and at runtime, the JVM will treat this as a module, and there you go, modules. There are two important features and two important concepts building on that. So the first concept is readability. When the module system, let's say the JVM launches and sees a module declaration, it will go through these requires clauses, and when module A requires module B, it will then let module A read module B. So this term readability will come up repeatedly, so it's important to understand the term. And then at the same time, the module system will check whether everything is there, everything that's supposed to be required, everything that's required is supposed to be there, and the module system checks that, and you get reliable configuration then. So you get this feature, this promise that it looks like everything's there. Then the second concept is accessibility. So if your module, in this case, the accessibility builds on these export clauses. In this case, the module B exports a package, and if you want to use a type from that package, then that type has to be public, and that's just like it is before Java 9. But also, it has to be an exported package, and you have to read that other module. These two things are new. And so these accessibility rules are also a concept that is new, and this will be that will come up repeatedly. And this is the feature you get from this, a strong encapsulation, which means as a library developer, for example, you can make sure that some parts of your API are public and other parts will not be visible outside your module. And if you're working on a big project, a big monolithic desktop application, for example, which has more than a single jar during development, maybe you have a couple dozen or even a couple hundred jars, then you can even use that in your own project, within your own project, to define for yourself, for your future self, or for your colleagues, like, look, this part is meant to be used outside of this jar and this other part is not. So I think that's actually, to me, this is the nicest feature of the module system, to be able to have something visible everywhere inside the jar, but not outside of it. So you're not supposed to see all the details here, although on this projector you actually can. And it's even outdated. There are no compact modules anymore. All I'm trying to show you is the JDK got turned into modules as well, even more than these. And this is a so-called module graph. You can see Java base down here, which contains object and class loader and class and all that kind of stuff. So everybody needs it. And on top of that, you can see things like XML, or there should be logging somewhere. SQL is there. well, so you get all the features that you used from the JDK are no longer in one blob. They're separate, split into different modules. And of course, you can write your own. So a little demo application that I usually show, and I will demonstrate later features by referring back to this application. And there are like 2-3 months a year where it makes sense to talk about an advent calendar. And unfortunately, we're not doing those months, so you got to ignore that. Maybe I should make an Easter calendar for the occasion. This is a really simple application. We're going to turn it into modules just so you get a feeling for it. So what does a calendar, advent calendar usually do? You get a calendar which has 24 sheets. Each sheet knows its day of the month, its day of December in this case, and contains some kind of surprise, which is an interface. Because it's Java, we of course need a factory. So we've got a surprise factory there. And we have 2 implementations. One creates chocolate, the other one creates inspiring quotes. And each of these classes is extremely simple. The only somewhat interesting code lives in the main class, so to speak, which launches this, which just creates a chocolate factory, creates a quote factory, puts them into a list, hands this list over to calendar, which has a static factory method, and then, by the draw of luck, it builds some quotes and some chocolates, puts them into the calendar, and then the calendar can be turned to text, and you can print it to the command line. So it's like a very, very simple application. This is the most amount of consecutive code that you will find in the entire thing. Oh, except maybe in the randomization. So now let's create modules for this, and actually you could go different ways. I just decided to go this way because you can demonstrate a couple things. I created one module for surprise and surprise factory because it looks like kind of like a nice API over here. I created one with the both actual factory implementations, which is down here, that's another module, and I want to have one with the actual advent calendar. With the calendar over here, and then advent contains the main class. So these are the modules I want to build. That means I have to create 4 jars actually for this project. And these are the dependencies between the jars, obviously. So these 2 factories implement this interface, so they need to know this jar and so forth. And now we want to turn this into modules. So as I said, you have to create a build that creates 4 jars, and then you put in 4 module declarations. So for surprise, it's very easy. You don't have to require Java base. As earlier said, you always need Java base because all these very important classes are in there. So the module system is not forcing you to always require Java base all the time. So you don't have to do that. And you only export the one package which contains these 2 interfaces. And the calendar is quite simple as well. It requires this module and exports another package, and factory is just the same. You can see where I'm going with this. Advent is a little more complicated because it requires these other 3 modules. What's interesting here is that it doesn't actually export any package because it's the application itself. It's not, nobody's planning to call into the application from the outside, so it doesn't export any packages. Oh, there you go. Now I know nobody builds things on the command line. I didn't either until I met the module system. To experiment with the module system, I can only recommend you use the command line directly, because build tools, like I usually used to say that Maven, 1/3 of the things that the module system wants you to do, it just does automatically out of the box. Another third is kind of complicated. You have to fight Maven a little bit on the way. And the last third, you sometimes just can't do it. It just doesn't work with Maven or Gradle. So if you want to get to know the module system, it's better to use it by hand, and then later try to figure out how to make your build system do the right thing. What we're doing here is we're building all these modules at once because we use a new feature, which is a module source path. You just tell it, so all my sources are in the source folder, and I want to build the module advent, and then it goes down, oh, advent needs these other 3 modules, so I'm going to compile these as well. So then you get all the compiled classes in the folder classes. Then you still have to jar them individually. So repetitive. An interesting thing is for the advent module itself, we can actually define the main class here. You would usually do that with a manifest, but now you can tell the module system directly, this is my main class. And then if you call it like this, you say, look, this is the folder with all the modules in there, please start the module advent. Then again, we look at the module advent, we'll see all the requires clauses, we'll check that the modules are there, we'll build this module graph, and we'll eventually call into the method, into the main method of the class that I defined here, and then the thing launches. Okay, that were the basics. Now I hope I didn't tell, well, if you didn't know the basics, I hope you kind of followed along. If you didn't know the basics, I shouldn't have told you anything new. So now I want to go into a couple of different things that you can do building on these basics. The first one are transitive dependencies. So regarding transitive dependencies, I would say not all dependencies are equal. So most dependencies that you define, you will use within the same module. So for example, you need immutable list, so require guava and use its immutable list. But you can also use a modules class on the boundary of your own module. So for example, you could return an immutable list from your public API. And transitive dependencies are about the latter, about the situation where you expose your dependency to your users. So let's have a look at this example from earlier. We have the surprise module here, and the calendar uses it. The thing is that the calendar has this create method here, and it takes a list of surprise factories. What that means is, in order to use the calendar module, I have to read the module containing surprise factory. So I always have to read surprise. So for everybody else, anybody else who wants to use calendar, I have to read the surprise module as well. If I don't read the surprise module, I actually can't use the calendar module at all. So how would I find out about this? The hard way would be try and error. I just try to use a module and then it fails, and I find out why it fails, and then I require that other module, and then so on and so forth. That wouldn't be very nice, so you don't have to go this way. Instead, what you can do is that a module can depend on another module and can add the keyword transitive. So that doesn't actually change anything for A and B. A reads B as usual, nothing changes here. But any module reading A will also be able to read B. So that's why it's called implied readability. It implies the readability. A implies the readability of B. So that means because for any module to access the types in B, it needs to read the module. Now it gets that reads edge for free. So in this specific case, we'll say calendar requires transitive surprise. And that means if Advent uses calendar, it reads calendar, then it also automatically reads surprise, and it can just start using it right away. There are some considerations when exactly to use this feature and when not to. I'm not going to go into that here, but I want to show you a couple of further applications that you can do with this. Because in the beginning, this sounds like a rather specific and somewhat benign feature. Okay, I can imply readability on some other module. But there are a couple of nice things you can do with that. The first one is you can create what would be called an aggregator module. You can say, for example, I have a huge application with dozens, hundreds of modules, but anybody who uses this one sub-project, so this one part, always uses these three modules. It's like 90% of the use cases where someone uses this one module, he's also going to use the other two modules all the time. So why not make it easier for them? You could create a module called Advent Calendar, which requires transitive these three other modules, and nothing else. It doesn't contain any code, it doesn't do anything. It's just there so that I can require Advent Calendar, and then I can read all these other modules for free. It would be like kind of that, so it aggregates the functionality of these other three modules. Earlier I told you on this big module graph that there were these compact modules that are not there anymore. The compact modules were aggregator modules. There's also a module called java.se. It's also an aggregator module. It just requires all the modules that make up Java SE. So if you want, you can require Java SE, and then you get the entire JDK modules, sorry, all the Java SE modules for free. So you wouldn't have to require individual modules. I'm not recommending that. I'm just giving an example of where aggregator modules come up. You can do other things with this as well. So with modules, it's a little bit tougher to refactor code, specifically if you ship this code and other people depend on it that you have no control over. So when you have a jar and you split up a jar, then usually it's not that much of a problem, because if the jar ends up on the class path, nobody really cares whether the code is in that jar or in that jar. As long as it's present on the class path, everything just works. This will not be the same with the module system. If you ship a module and then later decide to split it, and you remove the module with that name, then everybody depending on that module with that name will get either compile time or runtime errors, because that module with that name is not there anymore because you split it into other modules. What you can do then, you can have the old module and turn it into an aggregator module. So let's say we used to have a module called factories, and now we decided it got rather huge and want to split it up into a factory.api and a factory.chocolate and a factory.quote module. Then we can keep the factories module and just require transitive for these other three. And that means all the code out there that requires this module now can still see the functionality, because even though it moved into a different module, they can still read that module. So that might make sense if you're shipping a library or a framework, but it might even make sense if you have to refactor a module and in your own application, it's used like in 100 different places, and you're not ready to replace all the requires with the necessary individual ones. For example, maybe this 100 users of factories, some of them would just use the one and some would just use the other, so you don't want to go through refactoring all of these modules at once. Could be a lot of work. You can create this aggregator module, you could even put a deprecation annotation on there, and then you can remove it over time. You could also go the other way. You could merge modules with this. You could say, I find out that calendar, factories, and surprise, each of them just contains 1 or 2 classes. That's stupid. It just adds too much overhead. Why not collect all of them into one module? You could go the other way around. You could create this new module which contains all the code, and then the old ones, they are empty now and they require transitive the new one. So then everybody who reads surprise now also reads advent calendar and hence can still see the code in surprise. Important caveat here. Earlier when I just depended on surprise, I maybe just depended on the jar with a single class. Now that all of this went into advent calendar, now I might depend on a module which has like hundreds of classes. So, and there could be some other effects like service registries that we're going to look at later, which might have other impacts. So this is a bit more of a dangerous move. You have to look closely into the use case, or at least test closely to make sure this doesn't impact your stability. You could even rename modules this way. So all these things, we have to talk about this more intensively than with jars, because again, a jar is just a container. You can just rename the jar and nobody cares. But renaming a module is much like renaming a package. Like like your users will notice. And you can use implied readability to rename a module and keep the old module around with the old name. Again, it's just a hollow module, contains just the module declaration. It's just there. So if you used to read this module, now you can also read the new module, which contains the new code. Sorry, which contains the same code, but in a new place. So in summary, if A requires transitive B, then A reads B as before, nothing changes, but any module that reads A now also reads B, and you can use that, that's the primary use case, you can use that to make an API immediately usable, even though it exposes other modules types in its own API. But you can also create aggregator modules, and it helps you with refactoring when you split, merge, or rename modules. And I wrote a blog post about that where I go into a little bit more detail. Do you have questions about implied readability? So you can ask questions now, or if you don't want, you can ask questions later when you meet me, when you see me at the conference, just talk to me. Yes? So the question is whether there's any impact of the module system on existing code repositories. I guess you're thinking about Maven Central or something. Were there any surprises? Yes, there are. So for example, one thing that the module system does not allow is to have 2 modules that share the same package. And if that happens with jars, that's fine. With modules, it's not. And in those cases, if those jars get turned into modules, you could end up in problems. But the basic idea is that nobody's supposed to just turn the jar into a module and do nothing else and ship it. So it's important when you turn something into a module to seriously think about what you're doing, and you should be aware of the not shortcomings, but the additional hurdles that the module system put in, and whether you're running into any of those or whether your users will run into any of those. I have a big talk and also blog post about compatibility, but that's not this talk, unfortunately, so I can't go into details. But you can ask me later and I will happily tell you a little bit more about it. Oh yeah, in the back. So the question is there a change in performance when you use modules? So comparing Java 8 and Java 9 launch times is really tough because so many changes went into Java 9, right? It's really hard to track them down. My personal feeling is that Java 9 boots a little bit slower than Java 8. We have a large application which consists of 400 modules, not modules, sorry, jars, plus like our jars, plus like 150 something dependencies. It boots in like usually about 15 seconds on Java 8, and it's about 16 on Java 9, but on Java 10 it went back to 15. So the module system has a little bit of overhead, but it also improves a couple of things. For example, it now knows where exactly to load classes from if you use modules and not just plain jars. So yes, the module system added a little bit of overhead, but it also opened up room for optimizations, and I guess they're slowly being realized over the next couple of releases. So I wouldn't expect any big impact. In the mean, it could of course be that you have a very specific project which could, could be one of the outliers, could benefit a lot or could lose a lot. In the end, you just have to try it out yourself. Also, Java 9 comes with a new, makes the G1 garbage collection the default. So if you did not configure the garbage collection, you now get a different garbage collector, which could also very much change the performance behavior of your application. Okay, let's talk about optional dependencies. When you talk about dependencies, you have different kinds. One of them you just need to function, right? Those are like 95% of the dependencies. You just need that class, you need those features. If those features aren't there, there's no way for you to run your application. But there are other kinds as well. Maybe you want to use that feature only if it's there, but if it's not there, you're also fine. You'll just find another way to do your thing. And the last one is maybe you're creating a library that integrates with a lot of other libraries, or framework that integrates with a lot of other libraries. Then the assumption is, let's say, I'm a framework that integrates with Guava. Then the assumption is, if Guava is not there, then nobody's going to call the Guava specific code. So I'm not depending on Guava because I need it. I'm just depending on Guava. Like if you depend on it, I can help you with it, but if you don't, then I don't mind either. So these two cases are not really well mapped unless you come to talk about optional dependencies. Because what we discussed earlier is, let's say we have adapting code. So library may be absent from some deployments. Maybe it's a licensing issue or whatever. So you have some deployments with that library and a couple without. So we had this example here. Let's say we have surprise factory implementation. Each has its own module. But my idea is that maybe sometimes I don't want to ship all the modules with all the factory implementations. So that would look like this, right? Advent needs calendar, and Advent needs surprise as before. But these two ones, I don't really want to I don't really require them. If they're there, that's fine. If they're not, that's also fine. And the other use cases, what I said, were about the library that integrates with other libraries. It just wants to provide these functionalities if the other library is present. And if it's not present, the assumption is nobody is going to call into my library. So let's say we create a library called uberlib, which is not the damn company who took the damn name, but it's like Uber, you know? So it's the uberlib, the greatest lib ever, and it provides usability functions for various libraries, let's say for these ones. So anyway, with Cyclops and Waver and Commons Lang and Guava. And then once again, I don't really require these. The idea is if you use Commons Lang, then uberlib can help you, but if you don't, then that's fine too. The problem is that what we learned so far about requires clauses, requires directives, doesn't really help you with that at all. So what we learned earlier is, if I want to see code in another module, I have to require that other module. If I require that other module, the module system will make sure that the module is present at runtime, at compile time, at runtime. And if not, it will fail loudly. So that's not a good situation to be in. So I cannot really describe, like, if this module is there, I want to use it, but if it's not there, I'm fine too. That's where static comes in. You can use, instead of requires, you can use require static. So if A requires static B, that means at compile time, the module system will just treat this as if A requires B. B has to be present, and if it doesn't, it complains. Which makes a lot of sense, because if I want to integrate with Guava, I'm most likely going to compile against Guava's types. So then, of course, I would require Guava to be present at compile time. But at runtime, things are different. If B makes it into the module graph, then A will read B. But if B doesn't make it into the module graph, for example, because it's not present, it's just not on the module path, then A will just launch, the application will still launch, and A's present won't enforce B's presence. B can be absent and we can still launch. So let's give you an example. What I said earlier, the Advent calendar and the two factories thing. Let's say the module Advent now requires chocolate and quote factories, but it requires them statically. Static in the sense of not dynamic like at runtime, but static at compile time. Maybe not the best term. I think they tried to reuse the keyword here, I guess. I don't know. Kind of makes sense, but maybe not the best term. Anyway, so the point is requires static factory chocolate means at compile time chocolate has to be present. At runtime, it may be absent. Which means that at runtime, I really have to figure out whether it's there or not. And the best way to do that, well, there are different ways. You could technically just check whether some specific class that it's in there, whether it's present or not. And I think it's better to write a function that checks whether the module is actually present. And that function is, the first try, that function is pretty simple. You can ask the module system, like, look, these are all these modules. Is there a module with that name? And it will answer you. And there are some corner cases that make it more complicated. But by and large, it's very simple. You just ask the module system, is that module there? And so what I'll do here is, when I want to create a chocolate factory, I will check whether the module is present. And if it's present, then I can do this. And if it's absent, I return an empty optional. So the thing is, if I don't put in this check and I just do this, then of course I will get a class not found exception or class not found error when the module when the chocolate module is not actually there. So you have to have this check in there to make sure if it's there, then create the factory, and if it's not there, well, then you get back an empty factory. And presumably the code calling this is fine with factories being absent. That was the basic assumption. Now this is how our uberlib would look. We also require static all these dependencies. Here the interesting part is we will likely not check their presence. Because once again, if someone doesn't use Guava, he's not going to call us, giving us some type from Guava, right? So the assumption is if we get called, if our Guava specific part of our library gets called, then most likely Guava is already present, so we don't have to check ourselves. If Guava would not be present, the code calling us would already have failed. So there would be no runtime checks there. So to repeat, with optional dependencies, you use the keyword static after requires, and if A requires static B, B must be present at runtime, at compile time, but can be absent at runtime. And if you want to use B if it's there, then you have to check whether it's there at runtime. If you just want to use B, if someone hands you a type from B, then you don't have to check at all. You can rely on code before you would have having failed. And again, I wrote a blog post which goes into a little bit more detail. So now we have services. Let's see. Should start a little bit later. I still got a little bit of time. Great. So let's go into services. Oh, unless you have questions, of course. Do you have questions about optional dependencies? No. This feature was requested rather late. I think within the JDK, there's no use case for this, but the mailing list complained about requiring this feature for the ecosystem. Yes?
Can I define that I need at least one of these static dependencies?
So the question is, maybe in this case, can I be like, I need at least need one of these? No. You would then we would get a runtime error. But in the end, it doesn't make a big difference whether the module system finds out, like you have none of them, even though you want one of them, or you check that yourself as the first time you get called. So let's talk about services, and let's talk about dependency inversion. So everybody into architecture and design patterns, like this is something for you. I showed you this code earlier. There was all these dependencies earlier. There is a surprise API back here, and these two are implementations of that API. And then I said that Advent needs to require factory quote so I can create that quote factory, and also needs to require this module so I can create the chocolate factory. I would say that this is more like a low-level concept, and it's an implementation of an API, and this is a high-level concept, and I still have to depend on it specifically. If you would not think about modules, but think about classes, this would mean my class needs some interface, but I still instantiate that concrete implementation myself in the constructor, for example. And we usually say nowadays, don't do that. Have someone pass in the implementation that you need at runtime. Or any implementation, actually. So don't create it yourself. Let someone else do it. And so if you talk about API, then generally means the consumer of an API and the implementation should be decoupled. Both of them should know the API, but the API and the consumer and the implementation should not know each other. In this case, you saw that the consumer needs to know the implementation. And then there's a service locator pattern, which is one way around this. In the service locator pattern, you have someone in the center where you can register, implementers can register themselves, saying I implement this API, and consumers can go to the same registry and say, look, I need implementations of this API, can you help me out? And this service locator pattern is exactly what's implemented in Java. Interestingly enough, it's implemented since Java 6. You could already do this before, but the module system makes it more prominent. Before that, you have to put in files into your jar folder in the right places. With the module system, it becomes a little bit more prominent. And the idea here is that the modules declare which services they use, the other ones declare which services they provide, and then you have the service loader in the center as the service locator from that pattern. And then you have to go to the service loader if you want to load some services, as the name suggests. So you have a module A that consumes a service. So you use the users directive, and then here you have the fully qualified class name. So this now is not a module, it's not a package, it's a class. A uses this some service. And then you have also some service, if it comes from another module, you would also have to require that module containing the service definition. You would of course have to require that. It could also be inside A, that's not uncommon. And then the provider will say, I provide that service with this concrete implementation, and then that type would implement that interface. So the module system is kind of lenient. Service doesn't have to be an interface, it can be a class. I think even a final class, which makes no sense at all, but usually it should be an interface. So that now in this case, both of them know that service interface, both of them have to know the module where the service interface comes from, but none of them have to know each other. That means that A never sees these providers, which means, for example, if you add a provider, you don't have to change A. A just sees the API. And then the module system will pick up all providers. So in the beginning, when then JVM launches, when it looks for all these requires clauses and whether all the dependencies are there, it will also look into these uses clauses. It will see that module A uses the service, and they will check which other modules provide that service, and all the modules providing that service will also be pulled into the module graph. And then A can just do this to get the instance at runtime. So in our specific case, we have the advent module, which requires a surprise module because it contains this API, and we say we use this surprise factory interface, and then chocolate and quote factory modules, they just say we also require the surprise module because it contains the API, but we provide this interface with these classes. So the module graph looks like this, and as you can see now, the arrows have been inverted. This arrow no longer uses these specific implementation modules. Instead, it just depends on the API module. And then you have to call the service loader at runtime. This call to service loader looks like this. I remember the code that I showed you earlier, where in the main method would create a chocolate factory and would create a quote factory, would then put them both into a list and hand over that list. Instead, we do this now. We go to the service loader and tell the service loader to load the surprise factory class service implementations. And then you get a stream, and then we have to do a couple things. But in the end, we get a list of these implementations. And then the rest is as before. But what's gone now here is the reference to the specific classes of chocolate factory and quote factory. So in summary, you can decouple API consumers and providers by having the consumer use the service and by having the provider provide that service with an implementation. And then the module system plays the role of service locator in the center that you can ask for implementations. Questions about services? Yes?
What happens if you have two different implementations of the same service in two different modules that you import both?
So the question is, if you have two different implementations of that service, then like here, you get both implementations back. So now if you want to figure out, is this the right implementation? Maybe you're looking for something specific. You would have to implement that on your own on that factory. So actually the thing why you get a provider here, which I just kind of like went past, you can ask this provider, for example, for the annotations on that class. Yeah. Exactly. But what might happen is that you want to say, I actually just need one. In this case, we want to have all the factories for our surprises that we can get, right? But you might be in a situation where you say, no, I just want to find the one provider that does the thing that I want. And there are different ways to do that. One of the ways is that you put annotations on the providers, which you can check here, even before instantiating that, because that's a very, very lazy process. You could also have the surprise factory have some method. For example, you could think about this, the Java SQL module does this for SQL drivers. So you could basically say, okay, I load all the drivers, and each driver I hand off the connection string and be like, okay, this is a connection string, can you handle this? And then maybe the the SQLite driver will say, no, I can't, but the Oracle driver will be, I can do this. and then you pick the one that says yes. So if you want to have some logic in there that picks a service, you would have to implement it on your own, which I think is good because it means you can implement it on your own and you're not relying on the module system having some predefined structure. But there was a second question, I think. Yes? No. You get, no, it's not defined. You get back whatever. Yes. So that also means, for example, if you have a default, you could also, maybe you have a default implementation. Like I want to look whether there's a good implementation out there. If there's not, I fall back to a simple default implementation. Then you should maybe not do this exact process because then you would have to literally define your default implementation. What I would do is I would stream through all the external services, and if I would not find the one that I'm looking for there, then I would just create the default one myself. More questions? Yes?
This worked out without modules as well? Or with jars?
Yes, so with jars, what you would do, you would put all the information that's basically, wait a moment. Oh yeah, so the information that goes in here, you would have to put that into the jar. Not the one up there, you would not have to declare that you use a service, but if you provide a service, then I think in meta-inf there's a folder services, and then you put in a file which has this name, and then lists each implementation on a single line. And then you go to the service loader and ask them to load. So that feature's already there, and as I said, that's how the SQL module, now it's a module, but how the SQL portion of JDK8, for example, used to locate driver implementations. It uses this exact feature. And I think Log4j uses it. So this is it's a thing that exists, but it's not a very common thing because it's not very easy to use, it's not very prominent. You kind of like, it's hidden somewhere, you have to create this extra file. And now you already have the module declaration anyway, so now it's very easy to start using it, and I can only recommend to look into it. If there are no more questions, I will go to qualified exports. Or we could do, instead of going through more details, we could go to jlink, which is also a nice feature, which we're otherwise not going to look at. So you might have heard about this. You can create your own runtime images with jlink, and one of the arguments that Oracle is pulling regarding the removing web start or removing applets is basically the time where you have a JDK installed, like everybody has a JDK installed, and then you just ship the jars. That time is over. What usually happens now, if you have a big desktop application, you ship it with the JDK included. I'm not sure how much I follow that argument, but if that's the argument that's made, then you need something to make it easy to create an image that contains not only your code, but also all the things from the JVM that you need. And jlink is that tool. So remember this huge graph? Oh, sorry, there's a little lag here. Where all the JDK got modularized, you can actually use this. There are two things you can do. Let's start with the where you just create a JDK install just for your application. So if you know which modules your app uses, you can use jdeps to find out. Then you can create an image with just these modules. And to use that feature, your application doesn't even have to be in modules. Your application can be just in plain jars as before. You just run on Java. You just run on Java 9. But you can use jdeps, it's a command line tool, to find out about which modules you need. And then you can use jlink to create that. And this is how you would do that. You would call the jlink command and would say, I want this output in the folder JDK. And then you have to show it where it will find the modules that come with the JDK. In Java 10, you don't have to do this anymore, but in Java 9, you still have to. And then you say, OK, and I want to add these modules. These are the specific modules that I want in my image. And this is the smallest possible image. You just add the Java base module. And then you get something. You get the JDK folder. This is the one here. And if I go into the JDK folder /bin/java list all the modules you contain, then you usually get a huge list of like 150 or something modules. Here we'll just reply, I just contain Java base. Not exactly like this, but in this case it actually works. In other cases you might see services here as well. But in this case you will just get Java base in here. And if you need not just Java base, but your analysis of your application found out that you need like a dozen modules, then you just list a dozen modules here, and then you get a runtime image which contains just the modules you need and their dependencies, of course. So it's not just those 12 modules, it's the 12 modules plus everything that they need. So let's say you have a backend which uses all of these features. We would then say, again, I created in the JDK folder, I create my image with jlink. This is where you find all the modules. And then these are the modules I just put this command here twice to make it easier to read. You can list all of them there at once, or you can use add modules for every single one, doesn't matter. So let's say we use JAX-WS and some XML stuff, and this, what is it, JAX-B, and SQL, and of course we log something. So we add these, what are they, like 5 modules, and then the module system will determine which other modules you need, and will create you an image with just those modules, although in this case it could be a lot of modules. Apparently, these ones. Not, oh yeah, you get Java Desktop in here. Java Desktop is huge. It contains all of AWT and Swing, so it looks small, but it's rather huge. Still, so you get it's still not as large as the usual JRE or JDK that you would run on. So that was the first part where you create an image for your application to run on. Now you can create an image with your application included. But for that, your application does actually have to consist of modules. There are a couple of migration features which allow you to use the module system even though not all of your dependencies are modularized. It's called the automatic modules, or are called automatic modules. That doesn't work with JLink. So you have to have your code and all dependencies need to be modularized for this to work. This actually makes it easier because now you just say I want to create my image in the output in the JDK folder. Here are the modules from the JDK. Here are my modules. And my bestest module is Advent, so I want to start there. And because service is not resolved automatically, I add the 2 services as well. And then, in this case, my modules are also all included into the image that I come up with. And then I can just go jdk/bin/java, launch the module Advent. And I don't have to give it another module path because my modules are already in there. So I'm done. So if you use Docker images, for example, this could make it easier to package everything you need, not more than you need, but everything you need, and make it launchable with a single command. This is how to create a launcher. If you want to, you can just say launcher, and this is the name of the launcher, and this is the module, and maybe the main class, and then you get even a binary in Java in jdk/bin, which you can launch. Okay, there are a couple of more options. Summary we're going to jump over because time's out. As promised, a little bit about myself. My name is Nicolai, and I'm currently writing a book about the module system. I'm done with principal writing, and finally it's going to go into print. You can have a real copy from June on, but you can also already have a digital copy right now, which contains, I think, 13 out of 15 chapters. I write a blog. I recently started a YouTube channel. Not there yet, but more will follow. As I said, you can follow me on Twitter. And yeah, if you, by the way, there's a discount code. If you use that discount code, you get the book cheaper, and you make me a little bit poorer. No. So yeah, thank you very much. So as I said, if you have any questions, just find me out at the conference. Just whatever I'm doing at the moment, just interrupt me and ask me something if you want to. Bye, nice conference.